Okay, um, so three things. Number one, those of you for watching on Teams will know that, oh, I have to move around a little bit. Okay, so those of you watching on Teams are going to notice that the camera that is live um, is what we call the native camera rather than a desktop that is loaded into the screen. So in order to get this broadcast full screen, you need to right click on my camera and pin it, and it'll go up to full screen. Or you can view everybody else's icon. Whichever. I think you're going to find us more entertaining. So that's number one. Number two, for the live audience here, small addition to existing safety protocol. And I wanted to line this out with you. This is a result of a tragic accident at a chicken processing plant back east. And because we are in these wonderful hazmat suits, we want to leverage their safety and viability to the last possible second. And what that means is if for some reason we tell you eject your hood, take your hood off. Obviously you don't ask questions, you just rip that thing off. You do it right now, just as fast as you can. Because the only reason I'm going to tell you that is because your air supply has been compromised. Now, you can tell by the tone of my voice whether or not it means there's smoke coming down the line or whether or not the blower just got tired and quit. If the blower got tired and quit, I'm not going to be as excited because you guys have all disconnected your line and gone someplace else, so you know what that's about. But if I know the blower is going to stay down, I'm going to tell you to go ahead and disconnect and go ahead and put your street mask on. But if I tell you to evacuate, what I want you to do is I want you to take your hose off, stick your thumb over it, and run out the nearest door. Do not take your hood off. This is holding on to some precious good air for you. And in the case of the chicken processing plant back east, they had a liquid nitrogen spill and 5 people died and a bunch are on the critical list, and it's a very tragic situation. But they didn't have the advantage of this kind of safety gear. So since we have that advantage, we definitely, there could be a tank leak. We've got hydrogen, we've got propane, we've got nitrogen, we've got deuterium, we've got oxygen, we got acetylene. I mean, you talk about pressurized gases, we got a ton. And if for some reason something should happen and there would be an emergency situation and we yell evacuate, you again go to the nearest door, exit the door, go step well away from the building before you remove your hood, and then remove your hood. Because obviously you're disconnected. So doesn't do you any good to stay in it. Okay, so those things, we are back on regular schedule, and until I notify you otherwise, we're going to continue along the way that we're going. We are weighing a whole variety of risks and possibilities. I want to accelerate and bring some more people in, but we're going to have to get a couple more small pieces in place before we do that, just because there's time involved. And one of the things that we're going to do is a training thing you folks, if you notice, we've been processing you in one at a time. Well, I think you've got the hang of it. So, guess what? Next time, the first person in, I'm going to process them in. Then you turn around and process the next person in, and there'll be two of us doing it. And then the next time and then the next group that comes in, there's going to be theoretically four of us that are helping people get into their garbs. So there should be only 3 events, and we've got 8 people on board, just that fast. And I'd kind of like to follow that same pattern going out. We've got to do some testing, ask some questions about that, but that's kind of where we want to go with it, because it's that donning and doffing. It takes time to get people in and out of this protocol, PPE. Okay, David, you're up next.
Carl, we're still looking at the PowerPoint right to left.
Okay, you're looking at what?
The text it's mirrored, like you can't read it.
Yeah, the text on the PowerPoint is like mirrored, so we can't understand what it says.
Okay, hang on just a second here, because this is very interesting to me. I did a flip horizontal. It should be okay. Let me check. If it's not, I'll fix it. Dave?
Well, good evening, everyone. A little promo for next week. If things go as planned, we're going to be, I'm doing a thing on COVID-19. And I'll go over the immune system and the development of the virus and the mutations, and we're going to have a blast. If anybody knows what a blast is, it's a little more advanced in the biology schedules. You may not get it in your school. Anyway, I wanted to begin by talking about the homework assignment from last time. 8 of you did not do it. And quite frankly, that's not acceptable. If you don't want to participate, that's fine. We got other people who want to be involved in this, so you don't have to. But I don't like when I don't see them. A number of you, I said it needed to be turned in by 10 o'clock Wednesday night, and within an hour before and after, that's when I got a lot of them turned in. I recommend you do it a little earlier than that, so that if you run into a problem, you can text me or call me and get some help. I'd be glad to help, okay? I gave you a paper that said how to make a semi-log graph in Excel. Now, I went through part of it with you, and then due to technical difficulties, we didn't finish it. But I really felt like it's pretty well self-explanatory, and you could have gone through this and come up with the graph that you needed to. And you'll notice in number 9, it says choose logarithmic or exponential for your trend line. You choose the one that gives a straight trend line. And the majority of you who did this did not do that. Most of you ended up with a curve. In science, we like straight lines a lot. Okay? So you really need to do that, is get the straight line. And then I went ahead and made this graph from the data that we used. And I went ahead and changed some lines to red just for the fun of it, make them stand out. And that was not part of the instructions I gave you. Okay. A lot of you did not put in the limits for minimum and maximum so that your dots were all up in one corner. And that's not what you want. You want it taking up the graph quite well. and you need that straight line. And then I'm going to say that most likely I did not clearly state what I wanted you to do, because only a couple of you did it, where you took that graph and used that to figure out the sizes of the base pairs for the other two enzyme digest. Okay. Some of you did that, but very, very few. So I must not have been clear enough. So for those of you whose graph did not come out like that, I want you to fix that. And I want all of you who did not figure out the sizes of the other digest, the Eco R1, whatever you had, I want you to do that, figure those out, okay? Now, one thing I want to mention, oh, by the way, Caleb, Rishi, some of the best work I've ever seen. Really, really good. Well done. I do want to mention your results cannot be better than the data you start with. So if you start with whole numbers, you can't give an answer that's down to the nearest 10,000th of a base pair. You can only have whole numbers of base pairs. And actually that's logical, because you can't have a 10th of a base pair, or a 1,000th or a 10,000th of a base pair. You only have a whole number of base pairs. So you want to be careful about reporting that. That's what's called significant figures, or sig figs, and the rules for doing sig figs and calculations become quite complex. But for this one, it's just simply, it's got to be a whole number. You can't have half a base pair. All right. So a lot of you need to go ahead and redo part of it and do those calculations and send those in to me. Some of you put the original data on there. That's always good to have. I didn't require that, but it just helps. But that's what I wanted turned in. I wanted the Eco R1 and the BAM H1 digest, as well as the Hindi 3 that we started with. All right. Are there any questions about that homework assignment? One of the things we're taught as teachers is when you ask a question, shut up and wait to see if anybody's got an answer or a question for you. And I always count to 10 before I start talking again, or at least I try to remember to do that. Okay. That should be it, yeah. So, the last time we were looking at digest, enzyme digest. Tonight, we're going to go ahead and electrophoresis samples from that crime scene. Now, I sent out an email to everybody. Hopefully, you got it. Although I'm a little doubtful, because the email included a request that you send back to me what grade you're in, and only a few people did that. So I'm thinking probably you didn't see the email. But the email not only included the story of the mystery that we're solving, but also I threw in a data table for you to record the data from tonight. So if you haven't done that and pulled it up, I'm not familiar enough with the teams to know if you can have both up at the same time. Otherwise, you're just going to have to write things out. So we're going to go on into the lab now in order to get started. Carl. Someone grab my iPad. Would you mind grab my iPad?
I got it.
Thank you. So everybody take a seat at the table. And I went ahead and printed these out for you guys since you're here working with it. So, okay. These samples on this list get pipetted in here. So, take this off. And right there on the blue paint black stripe are the wells. And my angle isn't great. I think it needs to be pushed a tiny bit. There. Okay. So that's going to be well number 1, 2, 3, 4, 5, 6. And these 6 things are what you're going to pipette. And each of these are numbered for that. All right. Now over here, because once we get them pipetted, we'll do the electrophoresis, but then that takes a long time. And then they have to be stained, and then they have to be de-stained. You stain them with, in this case, Carolina blue, and then that's 20 minutes, 30 minutes. Then you have to de-stain by rinsing them in water, and you change it every 15 minutes for 2-3 times. Because of that, I have another gel here that we'll be able to use to go ahead and make measurements to get the data here. Okay? Now, when you're pipetting, yeah, put that one down. No, the other way. Yeah. It's nice down. So each time you have to change your pipette tip. Remember, you push down, now they're already set for 20 microliters, which is what the samples are, and you push down on the red button, and there's 2 clicks, and you're going to go to the first click, you put that to the bottom of the tube, slowly let it up, and then if it's all the way at the bottom, it may be sealed, so the liquid doesn't come in, so you slowly let it up so that it pulls the liquid up in. Then, using 2 hands to steady yourself in some way, however what works for you. And then you put it there, you're going to go into the first well, for the sample number 1, and make sure that you're not poking through the bottom of the gel. You want it to just be in the well. And when you dispense this, you try to do it slowly. Try not to pull it up out of the well. Do it slowly. And then don't go to the second click, because if you do, that's going to shoot air in there and push the sample up out of the well. Now, someone asked me last time if the wells could be filled without the buffer there. Well, if you do it outside, for one thing, the wells, the sides of it tend to solidify, harden over, so that then it's not going to electrophoresis properly. Another problem is that if you do it outside and then put it in there, handling the gels can easily break them. Also, when you do that, if you then add the buffer, it tends to wash the samples out of the wells. The samples basically stay in the wells because they are more dense than the solution that's out here. This buffer is tris EVTA, and the samples are in tris EVTA, and then there's a little bit of sugar added to it to make it more dense, so they'll stay in. I admit this is hard to do, and It'd be nice if we had practice, but we don't. So each of you will go around, each of you do one, and then a couple of you are going to end up doing a second one. So whoever wishes can start with number 1.
By all means, go ahead and ask questions, talk it through, confirm with David that what you're going to do next is what you should be doing next. You know, you use a lot of communication here. That way, less mistakes.
I'm having a tough time seeing the wells.
Yeah, me too.
Are they over the black strip right now? No, they're not. See, that's the problem. They've moved.
No, I think it moved back after you put it.
Okay, can someone else go ahead and
Actually, I can see them over the black strip.
can anyone else see them?
No.
All right, there's an alternative. If Carl, if you'll turn on the light, please,
Okay,
on that, and then if you'll just set
right, got it.
that up there.
All right,
I'm asking Carl to do it because he's got very steady hands, and my hands shake like mad.
okay, there are the wells, and they are now over the black.
Does that make it easier to see them?
Yep.
Okay, so what we'll end up having to do then is to rotate around
Okay.
so that the people are on the end when they go to pipette. So, Christina, why don't you start us off like that, and then open up tube number 1. Do check to make sure the liquid is all at the bottom. I spun these down yesterday, and they should not have changed, but we want to make sure of that. Yeah, there's a little tube inside the big tube, and so at the bottom of that little tube is where the liquid should be. So you push the red button before you put it in the liquid.
To the first click, right?
To the first click, yes.
Or just to where it stops?
Yeah.
Right? Okay, yeah.
And then put it all the way to the bottom.
Okay, and then let go
Yes.
of this.
That's perfect. Don't worry about putting the lid back on the tube. That doesn't matter.
Does it matter which direction I start in? Or which one I put it in?
Yes, you have to make sure you're doing, that you know what you've done. So
Okay.
it needs to go
And I just go into the...
into the well and dispense the liquid. Recommend 2 hands to steady it.
And then push the red button to release.
Yes. And then pull it out. Perfect.
Good job.
It's right in there.
And then this comes out when how you...
The wastebasket is at the end of the table there.
Okay.
There you go. Perfect. Okay, again, check to make sure that the liquid's all the way to the bottom of the inner tube. Great. Now make sure you're going into that second well. If you need to, you could always stand up.
Is there something grabbing you or noise is being made?
I'm not hearing anything. There. Say again, please. I can't see it from here, but it looks like it was perfect because I don't see any blue outside.
Yep, it was good.
All right. Evan, I think if you could move a little to your left, give him room. Yeah, perfect.
So it goes like in the little slot, right?
Yes.
Yeah, that one didn't look like it landed right.
Yeah.
Well, I see a little
It's
bit
like
of blue
part of
that's
it's
not
in, but
in,
it's like
but
spilling out, kinda.
is most of the blue in the well?
I think so.
Some of the blue hit the well.
Okay.
And then I put one here.
I think she got it.
Excellent. Just put it back in the block. It doesn't matter. It really doesn't matter.
Yeah, that was dead on.
Excellent. One to go. Looks like it, is there any still in there? It's weird because that does not, oh, I see why. It's up on the top. See if you can push it down with the pipette. Is that working?
He's got enough to work with.
But you have to be careful because you've got air at the bottom of that, and we don't want to push the air in. So you need to. Okay. I'll get another tube for that. Meanwhile, I've got a tube here for the number 3. So, get rid of the tip. Get a new tip. No. Okay, we've got a problem in that. These were not prepared ahead of time, so they're not all the way to the bottom. So we're going to centrifuge these.
Dave, if you just pass those over to me, I'll spin them.
10 seconds. Now that's the same procedure we used before, where we spin it for just 10 seconds and that makes everything go to the bottom. Okay, so first we're going to do number 3. Who's going to do it? Is that a new tip?
Yeah.
Okay.
We're gonna.
I'm not going to let you take the tube. I can't let you see what it says on the tube because I didn't get a chance to doctor this one.
Okay.
Perfect.
And I'm putting it in lane 6.
No,
or-
3.
Oh, okay.
Yeah, because 3 was the one that you only got a little bit
Yeah.
in.
Okay.
So we'll add a little more just to make sure.
I think that's it. It's a little better.
Okay. New tip. And this one is lane 6. Perfect.
A little bit of air.
Well, yeah, and actually there's a little bit here. I'd say do it again. And then bring it up very slowly. That time you got it all.
Christina, can you roll this direction? It'll give
There's
Caitlin.
still a little
Yeah,
bit
it's
of
okay. That's going to work. That's going to work just fine. All right. Now, I need for you to come over this way. Yeah, you can just roll. So we're going to set this on top, and the black wire has to be on the black end because that's the negative, okay? So if one of you will set that on top there. Yep, just like that. Okay, and now Carl, if you will move it into the hood, please.
Okay. What I'm going to do here, can I get you to hold this, Evan? Okay. I have to be able to see the water levels.
Okay, that's fine.
Okay.
I'm going to go over here. Very important, the red is positive. You put the red into the red on the power pot supply. So that's on there. It's all set and ready to go. I'm going to turn it on. And then I'm going to be here for a minute because I want to make sure it's running. And I'm going to crank the power up way beyond what the manufacturer said. Okay. Where did, oh, my iPad, please. Now, what I was looking for there was bubbles. There's a lot of bubbles coming out. What do you think those bubbles could be? Make a wild guess. We're running electricity through there. What does electricity do to water?
It ionizes. It's hydrogen gas.
Okay, it's what gas?
Hydrogen gas.
Which end?
Sorry?
At the positive or the negative?
Oh, at the negative side.
Excellent. Why?
Because hydrogen ions are positively charged.
Yes.
And what do they call that process?
Autoionization.
Sorry.
No. It's called hydrolysis.
Oh, electrolysis.
No, that, you take this and you cut off my thumb. Thank you. And the other end, of course, is what? What gas?
Hydroxide.
No.
What's water made of?
Oxygen.
And hydrogen. You said the hydrogen. So oxygen's at the other terminal. Now, which one's going to produce more bubbles?
Hydrogen, because there's two.
Excellent.
moles
The
per-
formula for water, H2O. You've got it. And the reason I'm messing with my iPad is that I want to time how long that's going. Okay, the orange block, you can dump those tubes into the waste. And I'll take the orange block. Now, this is one that I ran previously. So it's sitting in water. I'm going to dump out the water. Okay,
Dave, I'll take care of that.
Good. I don't want to reach there, and like I said, the gels are a little bit fragile, especially where the wells are, so they tend to break apart. And there's a ruler there,
Take that, please.
and you guys decide who's going to do the measuring. There's a ruler there, and you guys decide who's going to do the measuring. Okay, you're going to measure in millimeters. All right? Make sure you have the right side. We're not using inches. And if you need to, you can stand up. Now, one thing to notice on this, lane 6 is empty. That's because I didn't run that.
I'm going to rotate this so it's a little better camera angle. So
Excellent.
people can see the measurements.
So lane 6 is empty. That's the standard that gives you what's called a ladder. You know, you can determine how many base pairs are in each one of those segments. Well, we didn't run that, so you can't do that. But you can still get your measurements. And you're going to measure the one closest to the well, then the next one, the next one, the next one.
Okay, so I measure from the well to the first line.
From
And-
the side of the well that's closest to the DNA,
Okay, so like the bottom of the, yeah, okay,
Right.
got it. To the top
and then
or to the bottom
to
of the hash?
the bottom of the hash, yes.
Okay, got it.
Perfect. And all of you, I put pens and such there so you can go ahead and write.
It's a little tough to read the millimeters on here. Some of them have scratched off.
And then move further along. Don't
Okay,
start
yeah.
at 0. Technically, you should never start at 0 with the ruler because that part gets worn down. So you're better off to start further down on the ruler.
19 millimeters. And then I go to the second one. 25 millimeters. How many should there be? How many?
However many there are.
Okay, so if I can see a distinct one, then
You got it.
okay. Number 3 would be 27. And the next one would be 29. And then 39. 39 would be the last one. So I guess there's 5.
I have a question.
I really did not know how many there would be, so I'm glad we, so far, haven't had to go beyond the table that I made.
Marielle has a question. Go ahead. Marielle?
I was asking which lane are we looking at?
The first lane, lane number 1. That's the measurement she just gave you. So,
In lane 2, the first one is 18 millimeters. This next one is kind of tough to see because there's like one distinct one, and then there's kind of like a shadow of it around it. What should I do?
If they're very close, in other words.
Yes,
Um,
but one of them is darker.
then I would do my best to get 2 different measurements there.
Okay.
Why don't you grab her data table and fill that in for her, since she can't do it while she's measuring.
And for those of you who are wondering about the numbering on the ruler, those are centimeters, and she's counting the little marks, which are the millimeters.
Yeah, the second line would be 26, and then 28, and then 39.
So just 4 numbers on that one.
Yeah.
Okay.
I mean, it's so hard to tell.
I know.
Okay, so this would be in lane 3 now. 17, and then 28. I can see between those two there's like kind of, but they're so faint. Should I go
Do
for
your
it?
best.
Okay, maybe erase that last one. We'll try to do a couple more. Like 22 and 24. And then 28.
Evan, could you pull your wrists, gloves up over your wrists? We've got UV light going on in here.
This is difficult to measure because its stain is not really good. In a professional lab, in a research lab, they usually use ethidium bromide and then shine UV light on it so that it will show up real well. We can't do that, or I won't do that, because ethidium bromide is not only toxic, it's mutagenic, it's carcinogenic. So, does very nasty things to people.
Okay, so this is lane 4. The first one's 17. And then 25. And then 40. Okay, then the last one, lane 5. It would be 28 and 34. Just 2 for that one.
Excellent work.
Thank you for filling this in.
Could you repeat lane 1 if someone has it?
Yeah, 19, 25, 27, 29, and 39.
So, your assignment for tonight, your homework for tonight, is to look at those, look at the ones, what I told you each of those is, and the story that went with it, and see what you would figure out from that. What do you think happened? And I want a very brief paragraph written of what do you think happened in that room before the students got there. And then after that, a second paragraph saying, if you were the investigator, what would you do next? What would you want next? So that's your homework. And we're done with this. I'm going to stay in here to keep an eye on our gel that's electrophoresing. And you guys are going to go with Carl to the other room and work on something else. Yeah, take those papers with you. You'll want those. And don't be concerned about coming up with the right answer, because at this point, in my opinion, there is no right answer. I think you need more data. have fun rolling.
Okay, come here. Come on up. Next. Next. Okay. Everyone's got air? All right, hang on. Okay. Everybody kneel down. As you can see, you're all on camera. This is an activity on the floor. We're going to be working on the floor. And I'm going to explain to you what's going on here. We've been working on a solution for COVID, and you're all benefactors of it tonight, because what's happening is the air is getting irradiated with UVC light, a substantial amount of it, and we're in the process of building V2, version 2 of our COVID irradiator. This is V2. This is the central piece. This is the size of the V1. So you can see right away that the V2 is a full 2 inches in diameter wider. It's a 6-inch pipe instead of a 4-inch. And what that's going to allow us to do is place 10 fluorescent UVC lamps inside against the wall of this 6-inch pipe, and it will still, since the UVC lights are 1 inch in diameter, therefore you're still going to have a 4-inch core that's unobstructed. So we'll still be able to move the same amount of air down, except we've got 10 lamps instead of just 2. This will support 150 students, 1,500 cubic feet of air a minute, 150 watts of UVC. It will drink 300 watts of electricity. So substantially more power. Now, we're going to do something that we've had to invent. Okay, so this is part of prototyping. Prototyping, you can't just go out and order the pieces because they don't exist. You're building something from scratch. So we had to improvise a special saw to cut this pipe last night, and we've been moving along. I have a towel here. There's a little bit of stuff on the floor, just dust and stuff. But we're going to have to be careful because we're going to be applying a reflective tape to the inside of this tube. Now, if you look down, I've already put a strip in it. Can you see it? Okay, so that strip is perfectly smooth and reflective. It's an aluminum tape, looks like this, and we're going to apply a whole bunch of additional strips just as smoothly with no wrinkles. That's the trick. Now there's some challenges to making this happen. And you have to come up with a method of doing it. So if you reach over there behind you, you'll see a pair of scissors and a carpet knife and a piece of silver tape. So I want to give me all three of those. And I'm going to go through this and I'll show you how it's done once. And hopefully I can pull it off because I've never done it in rubber gloves. And that is going to be a unique challenge. It may not even be... Hello, test. Okay. Can you folks still hear me? All right. So, for some reason, my radio just flat dropped out. It isn't necessary for me to know whether or not... Oh, there it is. Okay. Okay, problem solved. All right. So, what we're going to do is we're going to take a piece of tape. Now this tape has a paper backing on it. And underneath that paper backing is the adhesive surface. And so we're going to take a couple of strips and we're going to tape this tape to this smaller pipe upside down so the adhesive surface is facing up. Then what we're going to do is we're going to take this tube and we're going to insert this tube inside of it with the adhesive tape facing up. Then we'll rotate the bottom tube until the one strip that we have aligns and we can see it. And then we'll rotate this so that when we piece together, it will very nicely press that second piece in the next sequential lane. That's what we're going to try to do. But by doing this, and these are fairly heavy pipes, we get a nice smooth roll and a nice smooth surface. So we'll begin by putting this here, and again, lots of wiping here all the time. Can anyone tell me why I'm so concerned about wiping things down? What happens if we get a bunch of dirt under the tape?
It sticks to the dirt.
All right, you're going to have bubbles, you're going to have, bulges, you're going to have problems. So to get the highest degree of reflectivity, we want to keep the inside of this tube as clean as we can. I should have vacuumed the rug before I did this, but we ran out of time. Okay. So, I'm going to begin by preparing a couple of strips that are going to be the hold downs. I'm going to stick one down there at that end. And I'll stick one down here at this end. Not too too tight, but just enough so that I've got them in position. Okay, so the next part is I'm lining this guy up so I can see how long my piece has got to be. So he's got to be about, at least about yay long. So I'll go ahead and cut that so I'm not having to fight with that. Now it's plain and easy. I'll have a little bit of extra coming out both ends, but this is what needs to happen. Okay. Now the next part is the part that's going to really be tricky with rubber gloves. And it's trying to get the backing to let go of the foil. And I did it. And I got it started. Okay. Now, I'm going to ask Christina to come over here. And I'm going to ask you to just kind of pinch the very end of this and hang on to it while I come down to this end. And you hold that there. And we're going to pull the backing off. So you hang on to that guy. I'm going to just put my thumb on this edge down here. He flipped up on me. Okay. Now what I'm doing right now is I'm moving this back and forth just a little bit while Christina's hanging on to it, making sure that this is as straight as I can judge it down the pipe this way. And then I'm going to take my end, remember that little piece I had, and I'm going to stick it on. Now I'll come back up and grab the piece that Christina's got, and I'll pull a little extra tension on it, and we'll grab this other piece that we had for that purpose. Just make one more guesstimate here. Does that look pretty straight? Okay, and we'll go down on that. Okay, now we have the tape loaded onto our other piece. So we're going to take this, we're going to load this into the system, and I'm doing this with my fingers cupped over the tape because the moment I touch that tape, it's going to turn to, and the whole thing will be a mess. Okay, so now it's sitting in the tube, but it's not in a right relationship with the other strip yet. And so we're going to hang on to this tube while we roll the bottom tube. And we're going to, okay, you're going to have to let go of that. And I have to do a judgment call here. Counting on the fact that when this rolls around, it's only going to overlap a little bit.
So you want the strips of tape to be right next to each other?
We want them side by side.
Okay.
Okay. Now that looks like it did it, so I'm going to go ahead and I'm going to rock this into place. knife because it's still taped. And we'll cut it free at both ends. As we rotate. Something ugly happening here. Okay, I see what went wrong, but we're just going to have to live with it. Okay, this is broken free. And this is broken free. So go ahead, pull that out of the way. And we have a problem here, and we didn't quite get the alignment we wanted. We're really close. Okay, so each of you take a look down inside the tube, and you'll see what went wrong. We've got probably a 32nd inch gap between the two pieces. It didn't quite overlap the way I wanted it to. But it's good enough. It's good enough. And if we discover it's a problem, we can always roll one right down the center and it'll cover both. But anyway, now you understand the process. Guess what happens next? You get to do it. Now, in this particular case, there was one other mistake I made. I put those two little end pieces on, and I misjudged where the end piece was, and I didn't quite have enough to cover out here all the way. But I knew that I could take a sliver. So we have our wonderful pair of scissors here. And we can make a little patch. We'll do that. Have any of you had the privilege of taking the tour at the Boeing Museum of Flight? Going down there and seeing the facility, the portion of the Museum of Flight has a section dedicated to the original factory where the very first Boeing planes were made by hand. And they were wood, and so it looks like a wood shop. And there's all these pieces of fabric and workbenches and chisels and hammers and all the stuff that you would expect in a wood shop. So, and they very definitely go through the same process of prototyping that you're seeing here. Now, What is the purpose of a prototype? Anyone tell me the purpose of a prototype in one word?
Well, not in one word, but it's a test to see if something works.
Okay.
Usually using materials that aren't quite as expensive as what you plan to use on the final draft.
So, ideally, a prototype validates your design. That's what you're trying to do, is validate the design. And so what we want to do with the prototype here is validate it, which is to say the dimensionality, the reflectivity, the number of lamps, the amount of air, all those things we can test. This may not be the ultimate material that's best suited for this, but what happens is after the prototype has been validated, we take the prototype and we hand it over to a manufacturing company. And they go through it, and they look at the design, and they look at it from the standpoint of, okay, how do we mass produce this? They're not going to start out on their knees on the carpet. It's not how they're going to go at it with a carpet knife. That's not. Okay, so what they're going to do is they're going to come up with a way to do this. We're going to go ahead. We've got a piece of sticky here that we really have some extra. I'm going to try to salvage this for the next two pieces for your ends. So there's piece one. Okay. I'm going to hand this off like that. He can go on the floor. Come after this guy now and see if we can. Okay, so we're now ready for you folks to take a swing at this. You've seen how I would approach it, but you might come up with a better way. So why don't you guys work among yourselves? You understand what we're trying to accomplish, and give it a spin. I'm out.
So we're going to want to get the right length on this, right?
Yeah.
So a little bit longer than
Yeah.
scissors.
Sure.
If you want to work on it at the same time too.
Oh,
One of
sure.
us might not. I don't know. This is tough. Oh wait, actually, I think I got it. it look straight?
Yeah.
You can do one side first and then kind of straighten it out after that side's done.
Oh, sure.
Okay, yeah.
Okay, go first. Okay. Is it good?
Yeah.
Alright. Alright.
Here, you wanna... I just don't wanna scratch off the tape that was there before. Why don't we get it close to the... Oh yeah, we have to keep going. Is it out on the other side
Yeah.
now? Okay, why don't we roll the whole thing closer to the floor so we have a better idea of where it's gonna land?
Sure. Okay, right here is looking good to me.
What do you... I mean, it's probably gonna be tough for you to see, but what do you guys think? Looking from the side.
It looks good.
Yeah.
I think it'll overlap a little, which is...
Yeah, I probably want it to overlap more than less.
Yeah, that's probably good, don't you think?
Yep.
Okay, so we roll the whole thing.
Yeah. Okay.
Now press down on that inside tube so it adheres solidly. Want to go ahead and make sure it really sticks down.
Okay, then do you think we got it?
I think so.
Okay, now you're going to have to cut it because as that tube rolls away, it'll try to pull the tube off. You've got to free it or it'll peel it'll try to peel starting at the ends. So you got to cut it free now.
Okay.
Oh yeah, we got it.
Looks good.
Now we just cut off the ends?
Yeah, so go ahead and cut off the ends. And I'll show you a trick with that. What you're going to do is you're going to take this, you're going to go on the inside and you're going to cut like this. So you're actually cutting against the surface. You're using the edge of this pipe to get a nice clean cut. Go ahead. Perfect. Exactly. So go ahead and do that on the other end. I assume you've got a piece over there.
Pretty small.
Please don't get your thumb in the way. I've only got so many Band-Aids. Okay, let's see how we did. Okay, well, we got a scrape in the middle, but it looks like it was in the tape that was already down. So your piece went down perfectly. The good news is see if I can pull that back. Yeah, it's a... I pulled it back, but it's on the side where we know there's a gap anyway, and we're talking about laying an extra strip to patch it. So one strip and that'll take care of it. But what you folks did was immaculate. So how can we avoid damaging the reflective surface in the future? Yeah, when you loaded this in, you loaded it with the reflective surface on the bottom. If you loaded it in with the reflective surface on the top, you wouldn't have had that problem.
Well, that'll work for the first half, but for the second half,
again, the amount of surface that's actually contacting is only about 1 inch wide. So you can take it right down to almost that last inch. And then in that last inch, what you could do is stand the tube up and lower the other tube into it to prevent that abrasion. Okay. All right, David, how are you doing? Are we ready for?
I've actually went ahead and stopped it and put it in the dye, the stain.
Okay.
So it's going to do 30 minutes in the stain and then start the washes.
Okay, how are we doing on time?
30 minutes to go.
Oh, 30 minutes to go?
For
okay.
the class, yeah.
Guess what? You guys get to do another strip. All right. So go ahead, because I'm going to be doing it all weekend.
I have a suggestion as how they'll do it in a manufacturer. They would take that long piece that gets the foil on it and cut it in half lengthwise. And then they put the foils in there, and then they put it back together.
Okay. So I'm... get out of the picture.
I just want to start laying out the
Another possibility is the manufacturer just might go ahead and have Alcoa make it for them.
Well, the reason that we're doing this is because it just so happens that only aluminum foil, or more specifically, only aluminum, has a high degree of reflectivity for UVC light. And so it's okay, make sure that it's straight.
Alright, does it look straight? Okay.
You can put the tape on the other tape first, and then you still can maneuver it.
Sure. Okay. Right here?
Yeah, that looks good.
Well done.
We want to make sure that...
we trying to stick it like on the next to the top one?
Just the overlapping, but we can like set it up here and then just roll it. Yeah.
Christine, is your mic on?
It's not. Never mind. Yeah, we rotated it close to the ground, like the whole thing, so that we could see. We really didn't have to roll too much, because the rolling is kind of hard to keep it even.
Okay, I think it's good.
Okay. You might want to, I can just see the edge of it. You might want to slice it while you can, because you can just see the edges on this side. And that way, as that pipe moves away, it'll tear cleanly. Now, after you got it sliced, go ahead and roll it back down and let it press again nice and tight. Okay, so it should come out, right?
That's good to me.
Got a good overlap? Wonderful. You guys are expert. Okay. I'm going to come unhook you and let you guys come on back to your tables.
Carl,
Okay.
the one above your head needs to be turned. The air is flowing, isn't it?
Oh, I see it.
Actually,
Okay. Okay.
yeah.
So to give you an idea where this is going, we have these two end caps. And when we're done, we'll put these end caps on. And each one of them is a 4-inch tube. So you have a 6-inch going into a 4-inch reducer. And you have one of these on both ends. And now you get an idea of what this thing looks like in its completed form. Now, there will be ballasts to drive the fluorescent lamps on the external surface of this. So what would you do as the next step after we get this thing foiled? What do you think needs to be done next? No guesses.
Add in UV lights.
Okay, after we get it done, you're absolutely correct. We need to mount the UV lights. What's going to hold the UV lights in? What do the UV lights need in order to operate, in order to work?
Electricity.
Okay, what's that electricity going to run through?
Ballast.
Okay, now the ballast is on the outside, the bulbs are on the inside. How's the electricity get from the ballast to the bulbs?
You're going to need to drill holes.
You're going to need to drill holes for what?
To run the wires through.
Oh! Do you suppose those wires, if they're fixed on the bulbs, would hold them against the surface of the tube if we pull it up tight through the holes? In other words, I have clip-on leads that we can clip onto the bulbs. We stick the wires through the holes, clip on the leads, stick them on the bulbs, then pull the bulbs up tight by drawing the leads back up to the surface, and then you bend the wires over, and they're actually holding the bulb against the inside of the tube. And again, this is a prototype. So as long as it doesn't come apart, and it serves to illustrate the point, and we can make our measurements, that's perfectly fine. So we're gonna drill holes all the way around. We're gonna have to drill 20 holes on each side, spaced correctly for each of these lamps. And then we'll put the ballast on, we'll run the wires in, then we'll put the bulbs in and connect the wires to the bulbs, and then we'll pull on the wires, which will draw the bulbs up against the side of the inside of this tube nice and tight, and then we'll tape those wires down, and those wires won't allow the bulbs to move around while they're inside this tube. And we can go ahead and complete our prototype that way. Now there's one last challenge here that requires some math. I've got 10 bulbs. Get ready to think. I've got 10 bulbs, and I can't turn on or off just one bulb because the bulbs are driven by the ballast. And each ballast supports 2 bulbs. So that means for 10 bulbs, I'm going to have 5 ballast. And I can turn that one ballast on or off. So every time I turn a ballast on, I'm going to wind up turning 2 bulbs on. Now here's what I want to do. I have 10 bulbs in here, and I want to offer the operator the ability, using just 3 switches, to select 2 bulbs, 4 bulbs, 6 bulbs, 8 bulbs, or 10 bulbs. So with just 3 switches, they will be able, in twos, to select any of those possible combinations, so that if they want to run half power or a quarter power or 3/4 power or whatever they want, maybe they don't have a need to run all the bulbs, they can run half the bulbs and leave the other bulbs as spares. So in the event that 2 of the bulbs burn out, they come over, they just switch that one switch off and switch the other switch on, and boom, they're in operation again. How would they do that with just 3 switches?
Of the 5 ballasts, you said there's 5, right?
There's 5 ballasts.
Would you need to connect 2 of them and then another 2? I was just thinking through, with one controlling 2 bulbs and then one controlling 4 and one controlling 4, you'd be able to do all those configurations.
You're spot on. Very good. And what what kind of mathematics are we talking about there?
I don't know what it would be called.
It's called binary. It's a binary numbering system. It's the basis of all computers.
Yeah.
And what you've done is you've got 1, 2, and 4. Those are your possible calculations. So in this case, we don't have 1. We have 2 and 4, and the other 4, which would make 8, right? So we can turn on 2, or we can turn on 4, or we can turn on 6, which is a 4 and a 2, or we can turn on 8, which is 2 4s, or we can turn on all 10, which is all 3 of them. So with just 3 switches, we can control 5 ballasts and 10 bulbs.
How will you know if a bulb burns out?
We're going to monitor the current. We know how much power this thing consumes, and each one of these bulbs is 30 watts. So we're watching the total wattage that the machine produces, and we're gonna actually have a current monitor on it, and software will detect if there is a shift in current. We're also going to have some other sensors, because you want to know if your airspeed drops. You want to know if a lamp goes out. You want to know if the main power to the blower drops. I mean, all of those are alarm conditions, and so they would trigger an alarm, and then based on the information that our sensors are giving us, we can determine the severity of the alarm, whether or not it's a full stop, or whether someone just needs to go perform a maintenance operation. We can actually program the control system to switch on the alternate bulbs if the primary bulbs go out. So if we lost a ballast, we'd lose 2 bulbs simultaneously. We know that that's 60 watts. If we saw a 60 watt drop, we'd know we lost a balance. If we saw a 30 watt, it's a lamp. So we can use some logic in the software to determine what we're going to do in each situation. the idea is we're going to, this system here is too big for our facility. So we can't run it here. But we are going to prototype it here, and then we are in a conversation with a company back in South Carolina, and we will work with them. They're the ones that make this hood, by the way. And so we want to offer them the opportunity, first choice, first right of refusal it's called, on this technology. See if they want to pursue. There is a lot of conjecture about how long is it going to be before we get back to normal relative to the vaccines and everything. If we're deploying the vaccine, and how long is it going to be before it's safe again? And there's a couple of real interesting questions that are going to affect the long term. Number one, I'm inclined to go ahead and continue with hoods because they offer us an extra measure of safety, because we're working with a reactor, we're working with chemicals and gases and all kinds of things, and it offers us a measure of safety. Since that safety's already in place, if I were a business owner, I wouldn't go out and buy this kind of protection for the risks that I normally face. But in this situation, since I've already invested in it, it's silly to not use it since it's here already. So because we already have it, we'll probably continue using it in a lot of the things that we're doing, especially in the biology department. It allows us to work with some perhaps a little more aggressive types of microbes than we would normally bring in, but we're not going to work with Ebola, we're not going to work with no. But there are some things that would normally be a larger risk, and we wouldn't bring those into a high school classroom. Colleges typically work with them all the time, but because of this, we call it PPE, we have now that's a game changer. Okay, so that pretty well wrapped up the time I have today. I'm going to go ahead and get in position. We'll start processing people out.
Very good. Don't forget your homework assignment. Don't forget to touch up the older one if you need to.